Let's solve some more questions based on remainder and factor theorem. These are questions from previous year's papers. First question is, find the value of k if this polynomial, cubic polynomial, leaves remainder minus 10 when divided by 2x plus 1. So that means the cubic polynomial 4x cube, that one, it's the dividend, and 2x plus 1 is the divisor. And they have told us that the remainder is minus 10, and we have to find this k, which is over here. That's the missing value. So now let us apply remainder theorem, which says that first, to find the value of the divisor, find the value of x for which the divisor is equal to 0. So 2x plus 1, if it's supposed to be equal to 0, that means 2x is equal to minus 1, or x is equal to minus 1 by 2. So for the value of x equals to minus 1 by 2, the divisor will be equal to 0. So this value of x we will have to substitute in the dividend. And generally we use a notation like f of x. So let the dividend be f of x, which is equal to 4x cube minus 2x square plus kx plus 5. fx is a polynomial with variable x. Now, if I substitute the value of x equals to minus 1 by 2 in the dividend, that gives the remainder after the division, and it is already given as minus 10. So I will say that therefore f of minus 1 by 2, that means when I substitute x equals to minus 1 by 2 in the dividend, this expression I'm expecting to be the remainder, which is given as minus 10. So let's plug in the value carefully. 4 into minus 1 by 2 cube minus 2 into minus 1 by 2 square plus k into minus 1 by 2 plus 5 should be equal to minus 10. Now let's solve this carefully. We will have 4 into minus 1 by 2 whole cube is minus 1 by 8, minus 2 into 1 by 4 minus k by 2 plus 5, or let's say we are moving the plus 5 to the other side, it will become minus 5. So minus 10 minus 5 is minus 15. Then this, if I cancel it, this is minus 1 by 2, and this is also minus 1 by 2, minus k by 2 equals to minus 15. So we are seeing that the left side has a common denominator of 2, and the numerator is minus 1 minus k. Now the 2 I can move to the other side. It will become minus 15 times 2, that is minus 30, and this is minus 2 minus k. Now let's move this to the other side and this to this side. So I will get k equals to 30 minus 2. So that means k value is 28. So they were asking us to find the value of k, and the answer is k equals to 28. Moving on to the next question. Using the remainder theorem, find the remainders obtained when this cubic polynomial is divided by x plus 1 and x minus 2. Hence, find k if the sum of the two remainders is 1. It is somewhat similar to the previous question, the same concept, but asked in a different way. So let's start by saying let the dividend f of x, the cubic polynomial, equals to x cube plus kx plus 8 into x plus k. Now this is divided by first x plus 1 and then also x minus 2. So we have two different divisors in our question with the same dividend, which is fx. And they're saying that the sum of the two remainders will be equal to 1. So let's find the remainders individually. Let's say that the remainder are 1 when we are doing a division with the first divisor x plus 1. Now if x plus 1 equals to 0, that implies x equal to minus 1. I am trying to find the remainder when the dividend is being divided by x plus 1. So the divisor x plus 1 is 0 when x equal to minus 1. So the remainder when we are dividing with x plus 1, we are expecting to be f of minus 1. That means substituting x equal to minus 1 in the dividend. So let's evaluate that carefully. Minus 1 cube plus k into minus 1 plus 8 into minus 1 plus k. So this is minus 1 and this is minus k plus 8 into minus 1 plus k. So minus 1 minus k into minus 1 is plus k. 8 into minus 1 is minus 8. So k plus k is 2k. Minus 1 minus 8 is minus 9. So this is the first remainder when I divide with x plus 1 as the divisor. Then let's look at the next one, the second remainder when we are dividing the polynomial fx with x minus 2. Now if x minus 2 is supposed to be 0, that means x equal to 2. So when I'm dividing the polynomial with x minus 2, if I substitute x equal to 2 in the dividend, that's going to be the remainder. So the second remainder is f of 2. So now let's evaluate the polynomial when x equals to 2. So that is 2 cube plus k into 2 plus 8 multiplied by 2 plus k. So 8 plus 2k plus 8 into 2 plus k. So that is 8 plus 2k into 2 is 4k, 8 into 2 is 16, 4k plus k is 5k, 16 plus 8 is 24. So 2k minus 9 is the first remainder, 5k plus 24 is the second remainder, and according to the question, the sum of the two remainders is 1. So I can say that r1 plus r2 should be equal to 1. So that means 2k minus 9 plus 5k plus 24 is equal to 1. Now this is a linear equation with variable k. We'll just solve it. So 7k plus 15 equals to 1. That means 7k equals to 1 minus 15, that is minus 14. So k equals to minus 14 by 7, that is minus 2. So we have found the value of k as minus 2. Now, if you go back to the question, they have also asked us to find the remainders. And we have found the remainders in terms of k. So when we plug in the value of k as minus 2, we need to find out what is exactly the first remainder and the second remainder. So the first remainder is 2 into minus 2 minus 9, which is minus 4 minus 9. That is minus 13. That is one of the remainders. And the other remainder is 5 into minus 2 plus 24. That is minus 10 plus 24. That is 14. That is the other remainder. So this is the complete solution to this question.